All right, guys, we're shifting gears now. We're going from strength to endurance. And the first thing that we need to realize is that unlike strength, where we don't need to have lots of energy, and energy isn't really a restriction or a limitation in our strength performance, what we're going to find really quickly is that our endurance exercise performance is basically going to be determined by how well we produce energy, how quickly we can produce energy, because the faster we produce energy, the faster we can go. The longer we can do that for, the longer we can go for. All right, so really what we're looking at here is we're looking at how fuel utilization is regulated during endurance exercise, because that's the first step. When we know what limits our ability to use or create energy, we know what limits endurance exercise performance. So by the end of this short series of videos, you should be able to list the fuel stores in the body and within skeletal muscle, outline the effects of exercise intensity on which fuel you use, state the endocrine effect on fuel choice. So what is it that epinephrine, which is going to be our hormone of choice, what does epinephrine do to the body? How does it change which fuel you use? You're going to be able to compare the adrenergic receptors. So those are the receptors for epinephrine and norepinephrine and other things. And you're going to be able to compare and contrast the alpha and the beta adrenal receptors, because that's really going to be important, because one of them is low affinity, but when it binds to it, it causes vasoconstriction. When it's high affinity, and when it binds, it causes vasodilation. And so when you're low level of epinephrine, you get dilation. When you're at high, you get constriction. And you're going to be able to see that across different tissues, these different adrenal receptors cause different responses within the cells. You're going to be able to provide evidence of the role of phosphorylase. That's the enzyme that helps to regulate glycogen breakdown in fuel utilization. You're going to be able to state the role of fiber type in fuel use and waste production. And you're going to be able to describe how diet can affect the fuel we use. And really the core of this whole series of videos is going to be a single paper done by Roman, which is one of the best exercise papers you'll ever see. And it really goes over everything about fuel utilization at different intensities of exercise. And it's really it's a classic paper that is wonderfully done. All right, so muscle substrates during exercise. So we can use all of these different things. We can use free fatty acids from the blood or the plasma. We can use glucose from the blood, and that's coming from either our liver, where the glycogen is stored, or from gluconeogenesis, when you take amino acids or 3-carbon sugars and you reconvert them back into glucose. And we're going to see that. We're going to talk about that. And so these are the ones that are coming from the blood. And then you've got intramuscular triglycerides and muscle glycogen. These are things that are coming from glycogen, from inside the muscle. So your intramuscular triglycerides and your muscle glycogen are things that you are storing within your muscles that are exercise. And then the last one is going to be lactate. And lactate, we all know, is lactic acid, this horrible thing that's going to limit exercise, that's going to cause you to become sore, and it's going to cause all of these. Don't believe it. It's a primary fuel during exercise. And without lactate, you actually stop exercising sooner. And I'm going to show you that as well. So all of these different things we can use to make the energy that we need in order to exercise and to perform that endurance exercise and go long and fast. And so really what we're going to talk about is how we decide which of these different fuels we're going to use to produce energy.